Good afternoon, everyone, and welcome to the second in our webinar series on how SD-WAN solves client problems and boosts partner revenues. Today's topic is no more dropped calls with SD-WAN. My name is Tina Plant, and I'm the Marketing Manager at Ecessa. For today's session, everyone is placed in mute mode. We welcome your questions throughout the presentation via the chat feature, which you can access from your control panel. Feel free to share your questions and comments with everyone. At the end of the presentation, you'll be able to unmute your microphone and ask questions live if you like. Today's session will be recorded, and we'll send a link to the recording in a follow-up email. Our presenter for today's session is Mike Siegler, CEO of Ecessa Corporation. Mike has a Bachelor of Arts degree in mathematics, a Bachelor of Science degree in electrical engineering, and a Master of Science degree in the management of technology. He has worked in engineering and technology for firms including Digi International, Seagate Technology, Medtronic, General Electric, and United Technologies, and we're thrilled to have him with us at Ecessa. To frame up our conversation, why are we here today? Because voice over IP and unified communications as a service are taking over the business world. But without the right network infrastructure, it can perform poorly and cause a lot of grief for your clients and your customer support teams. And it's not only VoIP, it's video conferencing, virtual desktop sessions. All real-time apps are vulnerable to issues related to poorly performing internet links. But there are things you can do to improve your clients' real-time application experiences. I'll turn it over to Mike now, and he'll tell you how.
Wonderful. Thank you, Tina. Good to see everybody online again today. Appreciate you taking out time in your busy day. This is, again, our second of 3 webinar series. As we talked about earlier in the year, a lot of the feedback we've received at different events and through different partners is we like the webinars, keep them relevant, keep them coming, open for suggestions on next topics. We have one more in the series that'll happen in August, and Tina will send out the link for that, continuing our discussions. But as we've talked about here today, it's all about, so what, who cares about SD-WAN? In June, we talked about avoiding outages, that simple resiliency play for that last mile. Today we'll talk about a little bit more detail on specifically voice and UCaaS, where very relevant today, some of the largest adoption out in the business world is completely reinventing that business communication. How do we make sure that it is robust, it is a positive customer experience, and it can still make you more and more money? So first of all, we'll start off with a polling question, and that is, based on your current experiences, how, of you out there selling to your customers, what is the mix of that UCaaS or VoIP? Is it cloud-based or is it locally hosted? It's amazing when I go to these different events that sometimes people tell me, hey, we're still doing some legacy stuff, but I want to get a sense of this audience as to what are you seeing in your sales today. Keep those answers coming. I'll check back with Tina here in a little bit. So first of all, to really get a sense of how SD-WAN can help with UCaaS and VoIP, we really have to kind of go to the nuts and bolts, right? What's the basic science of it? How do these things work? Well, fundamentally, we are all familiar with TCP traffic, our basic web traffic, and how that works in terms of I've got a traffic origination. It might be coming from a cloud-based application such as voice or other web type of hosting. And I'm going to my destination, my office, right? Someone's downloading a Netflix application. Well, with TCP, we're talking about a fairly robust protocol that's doing acknowledgments and is talking back and forth with the destination and the origin to make sure that traffic is getting through, right? So that there is a built into the protocol. You are asking for some TCP packets. They're sent along, and then there's an acknowledgement request in terms of, did you get the packets I sent? Or yes, I did get the packets you sent. Send some more, right? So you have a situation where this protocol TCP is adaptive. It's accommodating. It is listening to the success of the previous session that was sent or the previous packets that were sent. So in a situation where something isn't received or isn't received correctly because of a brownout or an ISP issue, loss, latency reordering, there's an opportunity with TCP to resend those packets and try again, right? Which is helpful when you're dealing with non-real-time traffic to try it again until you get it right. So even if you have to slow down that traffic from an overall throughput perspective, you can guarantee that you're getting something through that network. Now, when we're talking about TCP, or we're talking about voice over IP or unified communications as a service, a lot of times those are different protocols, right? They're either SIP or they're UDP streams. And in that situation, we're in a very different kind of configuration, right? UDP and SIP are really fire and forget. They don't have time to handshake and ask. Now, there are some hybrids out there that are proprietary and have one channel that's TCP for backhaul of metrics and the SIP path or a SIP trunk or a UDP stream that has that real-time traffic. Those are unique and those are somewhat better than a straight SIP or straight UDP stream. But fundamentally, when you're dealing with a more simplistic approach, SIP is going to send out a couple of packets, and maybe that third packet might get dropped because of loss. You might have a brownout, you might have some high latency, and that packet is essentially lost. And then in the stream come the next 4 packets. And that is that same phone call trying to continue to progress, but you've lost a packet. And maybe there's another packet that's out of order, right? From a reordering spike or something that's happening on that ISP link. And then maybe you drop another packet, number 9, but number 10 now is waiting in the queue. So on the receiving side, on that traffic destination, you're going to have a garbled message. You're going to have that breakdown, that breakout. You're going to have that situation where that call might be in jeopardy of being dropped completely. At least it's, or if it's not dropped completely, it's not a very positive experience for the end user. So again, these SIP and UDP streams are very susceptible to packet loss, latency, reordering, even partial outages from different ISP vendors. So any of those interruptions to that real-time traffic stream is going to cause either the call to be dropped, or it's going to cause that call to have poor quality, or it's going to create this quantization noise. There's a lot of different ways that we experience bad call quality. Normally what I use for an example is on your cell phone, right? It's a very similar situation where when you've only got one bar on that cell phone, it's going to start to act kind of quirky versus if you're using a Wi-Fi support or you have plenty of bars on that phone. It's the same concept, different medium, right, in terms of wireless versus wireline, but a similar concept from a signal control perspective of you don't have all the packets in the order they need to be at the time that you need them for that receiving side to put it all together in a coherent way. Okay, hopefully that makes sense. I'll monitor for any questions that come up. Okay, so because SIP and UDP, the fundamental protocols that are being used by VoIP and UCaaS are a lot more sensitive, right? They're fragile. And what we want to be doing then is making sure that we are building a more robust environment. Now, as we talked about in a lot of our calls with customers, it's not always the headquarters or the data center that has this issue. It's typically that last mile. It's a rural location that may not have the most robust broadband, that may not have the most robust DSL lines. And that is where people will experience the poor performance. So a lot of times we're not talking about major cities and major data centers that have these issues. A lot of times they're connected to a very good low latency pipe that does not have this experience, or an expensive MPLS or T1 that has a guaranteed bandwidth. But when we've tried to put more of our traffic over commercial broadband, best effort internet, these are common occurrences. So what do we want to do, right? We want to make sure that we're building out the how robust that last mile is, right? So today, as we've talked about before, businesses operate on one internet connection, right? Residences operate on one internet connection. We want to make sure that we are not letting that happen for our business critical customers, that we are advocating on their behalf, that they are thinking proactively about building out some resiliency and some redundancy. So we want them to be able to avoid those basic outages, and we want them to be able to create a second connection of some kind, right? And as we've talked about before, we can integrate any kind of secondary connection. That can be 2 broadbands, that can be an MPLS and a broadband, that can be multiple DSL lines, that can be a cellular, that can be a satellite. It can be any kind of connectivity that gives you that second opportunity to continue the path of those UDP or SIP streams. So we'll talk a little bit more about that. So how does SD-WAN ensure that those calls never drop? And these are kind of the discussions that we typically have on the deployment side of an SD-WAN solution. People typically get a sense of, hey, if I have SD-WAN, I won't drop a call. Great. But as we talk about in our discussions, it's all about architecture, right? There's lots of different ways to solve that problem, right? In some cases, if you look on the left, right, you're talking about a cloud-hosted PBX or a cloud-hosted platform like a RingCentral, like an 8x8, like a Jive, whatever those might be. There's a lot of them today. And they're going to essentially have their applications in the cloud, either their cloud, public cloud. It's a mixture, right? And in that situation, your remote offices need to connect into that cloud in a robust way. Now, again, if they're single-threaded, a single ISP to the cloud, you're going to take your chances. Each protocol or each application is a little bit different in how it handles that traffic. But fundamentally, that concept of SIP and UDP streams being dependent on the quality of those links still holds true, right? So as you're trying to deploy a new UCaaS or SIP voice over IP system, you want to have that same concept of multiple connections bookended with SD-WAN. So how does that work, right? So what we would advocate for a cloud-hosted environment would be one of our virtual instances in the cloud environment, either public or private cloud, and then applications or appliances at each of the different remote offices, which then you can create the SD-WAN tunnels, and you can create a never down environment between the remote office and that cloud-hosted application. On the right-hand side, which is maybe a more legacy approach or that hybrid approach, you're going to maybe have a PBX or an on-prem solution at a headquarters or a data center or a colo location. In that situation, it's the same architecture in terms of remote offices having an SD-WAN solution, the head end having an SD-WAN solution, and creating the tunnels that allow you to create a never down environment from site to site. Now, the one thing I didn't show on here, and many customers require this, is you can also support a full mesh with SD-WAN. So if you need to have office-to-office communication, you need to have low latency video, security cameras, or whatever it might be from office to office, the solutions can also support that, creating tunnels from remote offices to remote offices. So it's not just a hub and spoke, but a lot of times when we're talking about voice, this is the traditional topology that people want to deploy. Okay, so again, so what, who cares? How does that tunnel create a never down environment, right? And this is where that concept of create an insurance policy for your network, right? So what we do at Ecessa is we use packet level and session level duplication. So what we do is over the multiple connections from a remote office to a data center, we make sure that we say we want to prioritize our voice, right? There might be other applications for business that are as equally important or more important than voice, but for this conversation, we'll just talk about voice and UCaaS. So what we can do in our quality of service setting is prioritize that UCaaS or voice, make sure that we are duplicating that traffic across those multiple connections, so that you're essentially spreading the risk out across the different connections from the remote office to the data center. Whichever packets get to the receiving side first win, as it were. You don't have to worry about loss, your reordering, or your jitter, because you're essentially bypassing or throwing away any packets that show up late or show up out of order or don't show up at all. Now, again, if you take that mathematical approach, if you add 3 connections or 4 connections, you're building out the capability of that network even farther, right? So for example, if you are a bank or if you are a mission critical industrial provider, you may want to have 3 connections and provide this type of resiliency so that you have that backup, you have that redundancy for every packet, specifically real-time traffic. Okay?
We do have a question.
Oh, yes.
And the question is, if the hosted provider does not allow you to place a device, whether hardware or virtual, in their environment, how can you send packets over 2 connections if the provider generally needs to see 1 IP address, and if the second circuit sends it, may not recognize the IP address? It's
a great question. It's a great question, yes. And this is becoming the norm, right? So what we find is that a lot of the cloud-based SD-WAN providers are providing their own gateway in the cloud, right? So they have a controller in the cloud which manages the different IP schemes from the cloud to the remote site, and they essentially convert the different IPs into effectively one IP that goes to the provider. Now, Ecessa can do the same thing because we can spin up a virtual instance in a public cloud, right? If that's AWS, if that's Azure, if that's in VMware, we can essentially say, where does the customer need to have that virtual instance in such a way that it can be set up to create that single IP failover for people. Yep, that is how we're going to do that. Okay.
Okay.
All right. Keep the questions coming. All right. So where have we seen this before, right? So where have the so what, who cares on case studies? Okay. So one of the more, I think, relevant case studies we have, and again, just taking a step back, Ecessa has been around for a long time. We have a lot of satisfied customers, a lot of case studies. Encourage you to go out to our new website, take a look at those case studies, submit your questions. We can do a follow-up, a personal follow-up if you have specific items that are not covered in any of those case studies. But Summit Partners is one that's very special to us. Summit is a venture capital firm that has offices around the world. And obviously, they're dealing with very large transactions. They're dealing with hundreds of millions of dollars in VC funding for specifically healthcare types of companies. What they had done is set up a video conferencing system across their different offices, right? So Menlo Park, California, London, Boston, they wanted to be able to have real-time video, flawless, right, from site to site, right? And as they're trying to, broker deals and finalize negotiations, just like law firms, just like accountants, just like banks, they do not want to have those interruptions. For the case of downtime, just pure reputation, right? They want to make sure that, hey, we are world-class in what we do. This is important to us. So they had deployed riverbeds prior to us and had tried to kind of optimize, cache, dedupe that type of that traffic. But as we know, real-time traffic isn't well positioned for that. We can't buffer it enough, especially when you're talking about video, where you're trying to have a conversation between London and Menlo Park. You need to keep that latency very, very low. You can't have that buffering. So we deployed our WANworks product across that network in full HA pair in combination with their riverbeds, so they could keep that investment and deploy our product to help them maintain the real-time traffic. So we did exactly what I showed in the previous diagrams. We prioritized that real-time traffic, that video conferencing that they wanted. We gave that priority in the network. We duplicated that across multiple connections that they had, and they essentially were able to have a never down environment where, again, we essentially improved the packet loss overall by over 98%. Where they were monitoring that on a per packet, per session issue, we were able to reduce that significantly. And even in the first 2 weeks that we were taking detailed measurements for their proof of concept, we showed them that they avoided 9 mini outages, which again is just more kind of ammunition for the partner to say, look, this is how we can take your problem and make it go away, right? Especially something as critical as video conferencing across the globe, right? Next is a little bit more close to home, right? So Capital Electric is a co-op, right? It's an electric co-op. And this is a smaller organization, and this is a rural organization. And essentially, they have a couple people in their office who are taking phone calls from their members. They are processing credit cards. They are processing billing. They have an online, an online system that they have to have up and running. And in this situation, they had outages, they had disruptions, and again, it was inconvenient for their staff. It was a reputation hit for them. And then essentially, they reached out and worked with us through a partner to deploy a PowerLink, right? A simple failover device to help make sure that they were never down on their voice, right? And making sure that they were up and running at all times. So you can see there that the solution there was it was a cheap insurance policy for their business continuity, right? And that is fundamentally what we continue to talk about today, even though SD-WAN is much more adopted and understood than it was 10, 15 years ago when we started. It still continues to be how can this help a company? So again, encourage you to leverage the case studies that we have. Ask us for those that any questions you might have about how we did that specifically to solve those issues. And the last one that I'll share today was an MSP. Again, smaller organization, but was hosting some of their own VoIP services. and also servicing up cloud-hosted VoIP. And again, same thing. They wanted to be able to provide a solution to their customers that was going to provide them some resiliency at the edge, that never down voice, right? Something that was easy to install and cost effective, right? So effectively, their result was no more dropped calls. And again, that was a specific situation where they had multiple customers demanding a more superior product than what was being deployed at the time.
We have a comment, if you will. Obviously, nothing works during power outages, right?
Very good point. So what I do at my house, I actually have a battery backup, right? And what we have in the office is UPSs. So I would say, yes, you can actually. You can maintain internet connectivity even when the power goes out if you have UPSs for your modem, your Ecessa, and then any other, maybe your core switch, right? So if you've got a UPS set up, you can absolutely have internet connectivity when the rest of the building is out of power. And I've done that before. So, but yes, good point. We just had storms roll through here in Minnesota yesterday. So it's top of mind for everyone. So battery backups, Ecessas, multiple internet connections. All right, good questions. All right, so what's the value of SD-WAN in your portfolio? And we talked about this last time a little bit, tried to fine tune it to, specifically to UCaaS and VoIP, right? So to a client, it's the same concept we've been talking about, right? You want them to eliminate outages, be never down, right? You want your business to remain up and profitable. You want your reputation to be intact. You don't want your employees to have to go home because there was a 30-minute, 60-minute, 90-minute outage, right? Keep those folks engaged, keep them productive. You want to make sure that you are scaling in terms of new offices, right? So a lot of times we find when people are ready to plan for a new office, plan for a new data center, this is one of those things where perfect opportunity to say, plan for the future, right? Build it now. It makes it easier to deploy additional technologies in the future as well. Okay, on the partner side, your benefits, right? First and foremost, you're out there making money on UCaaS. You're out there making money on VoIP, right? It's going to continue to be a very lucrative space. Add a level of confidence to it. Maybe the next polling question can be, how many deployments have you had where you had issues with internet performance or with poor performing real-time traffic, right? Because that's an indicator. If you're having those issues, there's an opportunity to deploy an SD-WAN solution to give you more and more confidence in that deployment. Secondly, right, you can also start to build a more comprehensive offering for your customers. It's not just onesie twosies, it's a package, it's a bundle, right? If I'm selling UCaaS, I want to sell SD-WAN and a second circuit, right? So it becomes a more rich offering that you can provide to your customers. So that's another benefit. And then third and foremost is again, future-proof, right? This is not, so outages being unacceptable might be a new concept to some businesses, or it might be an old adage to some very, progressive, long-standing customers like our Summit Partners example. But in the future, right, avoiding outages, having multiple connections will be the same, will be the standard, right? That will be the industry standard. And so you can be in front of that now, that trusted advisor recommending to people, they may not always take the advice right away, but you can be on the right side of history, as it were, and say, this is where things are going. Highly recommend you take a look at this, and I can help you, partner, right, to set this up for long-term success and future-proofing your network. Okay? Are there any other questions there?
We have no new questions. Feel free to keep sending them over, folks.
Okay. Well, fundamentally, that's the material I want to get through today. I want to answer any questions that people have. But as always, we've got more interesting information out on our website. We have a lot of technical material on our tech support page. And again, as a partner, you have a lot of benefits that you can engage with us. So please visit our website at ecessa.com/partners. There's a lot of different things that are available to you. Okay. And I will open it for questions. And of course, before you leave, you're going to want to email so that you can be put in for the raffle.
Right, to win an Ecessa Edge, because there's no better way to understand the technology than to use the technology.
Absolutely.
And email number 2 to partnerinfo@ecessa.com. Also on August 20th, that's our third in this 3-part series. The topic will be faster applications with SD-WAN.
All right, if there's no questions, I'll give 5 minutes of your day back to you Thank you for joining once again. Look forward to having you on our August webinar next month. And again, feel free to reach out to us at any time to engage and ask more detailed questions offline. Thank you, everyone.